Algebra 1 students, welcome to your final video lesson of the semester. Let's finish this strong. Today we're going to look at the standard form of the line. It's written in the form ax plus by equals c, where a, b, and c are real numbers, and this is missing here, but a and b are not both 0. Had a couple little mistakes on this page. There's one of them. The second one's coming. Although this standard form isn't quite as nice as our slope-intercept or point-slope that we've already studied when it comes to graphing, we can still use it, and it's relatively pain-free just by finding x and y intercepts. Now, here's the example. 4x plus 8y equals 16. If you were to plug in 0 for x, as you can see here, you get this basic equation. 8y equals 16, a little division, and y equals 2. Now here's where that mistake was made. On your notes, change this. I had a typo on both of these, but this is actually the y-intercept at the point 0 and 2. By the same token, to find the x-intercept, you'd plug in 0 for y, so 4x plus 8 times 0 equals 16, and you can go through and find that 4 would be the x-intercept. Now, as long as you graph those 2 points, you have a line just simply by connecting them. All right, so let's find the x and y intercepts of the standard form equations that you see here. If we plug in 0 for x, we would have 0 minus 5y equals 40, or just simply negative 5y equals 40. Divide by negative 5. Divide by negative 5, and you would see that y equals negative 8. Our next step is to plug in 0 for y. So we'll have 4x minus 0, or just simply 4x, equals 40. Divide both sides by 4, and x equals 10. So we have x and y intercepts of 0, negative 8, and 10, 0. So 0, negative 8 would be your y-intercept, 10, 0 would be your x-intercept. All right, same idea on number 2. Now, one little trick you can have, if you use your finger and just simply cover up one of those terms like I'm doing there, you'd have your equation. So we would know 9y equals 10, so y is 10 ninths. And you can leave it just like that. If you prefer 1 and 1/9, that's totally fine. Now you can again use your finger to cover up the second term. Negative 2x equals 10. Divide by negative 2. X equals negative 5. This gives us our two intercepts, 0 and 10 ninths, and then negative 5, 0. Why don't you pause the video and do the next two and then compare your answers. Okay, now you can see the answers for 3 and 4. Make sure yours match, and if not, pause this screen, get it copied down correctly so you'll be ready to go. All right, now we're going to go one step further on these next two problems. By not only are we going to find the intercepts, but we're going to use those to graph. So let's look first at number 5. If x is 0, we would have the equation negative 2y equals 10. We can divide by negative 2, so y would equal negative 5. In the same way, if we plug in 0 for y, we'd have 5x equals 10. Divide both sides by 5, and you get x equals 2. That gives us our two intercepts, 2, 0, and 0, negative 5. All I have to do now is go and mark those 2 points, 2, 0, 1, 2, 3, 4, and 5. And I'm going to grab a line tool here. You can just use your pencil and connect those. And it should look something like that. All right, again, why don't you pause the video do number 6. And you can graph it on this same coordinate plane. Okay, you can see my graph now. The purple line was problem number 6. You can see the two intercepts are 0, 4, and 8, 0. You can also see the process and how I found them. All right, let's continue. Vertical versus horizontal lines. We're going to go through this topic pretty quickly. But just a little reminder over here on the right, Hoivuk's horizontal lines have a slope of 0, and the equations are in the form y equals a number. It could be any number. Where vertical lines have a slope that's undefined, and they're always in the form x equals some number. So when we look at number 7, I'm going to grab a green line here. It's y equals, that tells me right here, the hoi part of Hoivuk's, that it's a horizontal line. And we know it's at -4. 1, 2, 3, 4. So all I really need to do is that. And I'm going to underline this in green so you know which line goes with which problem. Whereas on number 8, I'm going to change color, x equals 5. This is an x equals equation, which corresponds to the Vuk's portion of Hoivuk's. Be careful when you say that. And we know it's vertical, therefore, so x equals 5. I've counted 5 spaces, and it would look something like that. And again, I'll underline it just to color code things. All right, why don't you go ahead and quickly do those next two, and I'm going to put those answers up, and then you can compare. Okay, now you can see my solutions. The one thing I would think that could be somewhat of a challenge for you is this last one, y equals 0. It's horizontal, obviously, since it says y equals. The trick is y equals 0. Well, it sounds simple, but sometimes it can be a little confusing. When you see y equals 0, that's a horizontal line that has a y value of, well, 0. We have another name for that, though. That's it's the x-axis. Okay? So anytime you're equal to 0, it seems like it should be simple, but it can be confusing if you let it get to you. All right. Next, write the equation in standard form. Now remember, guys, standard form, that's the form we started with. ax plus by equals c. Using integers. In other words, no fractions or decimals. All right, so here we go. To get things into standard form, ax plus by equals c. I look at number 11, and the first thing I notice is I have 7/3. We don't like 7/3 because it's not an integer, so I'm going to multiply both sides of the equation by 3. So 3y equals 7x minus 6. The next thing I'm going to do is subtract 7x from both sides, and now I'll have negative 7x plus 3y equals negative 6. Now some people are picky about not wanting that first term, that a term, to be negative, so you may see this written as 7x minus 3y equals 6, where essentially we just multiplied everything by -1. However, being the nice guy that I am, I'm totally fine if you want to leave your answer as negative 7x plus 3y equals negative 6. All right, number 12. Same instructions, but notice this time we're starting in point-slope form. So what I'm going to do is actually start by doing a little distribution, 3x minus 15. Now, we need to move the x and y terms to the same side of the equation. I also need to move the constants, the numbers, together. So I'm going to do that first. So y equals 3x minus 23. And then finally, I've got to move that 3x. I can do that by subtracting. So negative 3x plus y equals negative 23. Now again, just like we saw in the last one, you may see some people that prefer multiplying everything by -1 so that your lead coefficient, the A term, is positive. But again, for me, it's not a huge deal either way. I'd accept either answer, full credit. All right, same instructions. This time you do them and pause the video, work through them, make sure you know what you're doing. All right, you can see my work on both of these problems. The first one, I had to get rid of the fractions, multiplying everything by 5, took care of that real quickly. And then it was simply a matter of rearranging. Now again, we had that negative A value. We could have done this by multiplying both sides by -1 and written it as x minus 5y equals -2, but again, that's more personal preference than anything else. Then you can see on 14, it started in point slope form. I distributed the -2, and don't forget, -2 times -5 is indeed a positive 10. Then add 3 to both sides, and the equation starts to come together. When you finally, into standard form, when you add 2x to each side, you've got it. Now, folks, when you come to class on Monday, I'm going to have a little notes quiz for you. So make sure you've taken notes accurately and you have all the answers right in front of you so you're ready to roll Monday. Hope your weekend is spectacular.